out, Brent. Give me like 2 seconds to write down.
Jose, can you lights for me, please? Yes, all of them. Turn them all on. Okay, so what does a satellite have to have? What velocity does a satellite have to have to maintain an orbit that's 200 kilometers above the surface of the Earth? Okay. So in this problem, what do we know?
We know 200 kilometers.
Okay, so we know our radius is 200 kilometers, right?
Yeah. 200,000.
Just 200 kilometers?
No, you have to convert it to meters.
Okay, we're going to convert that to meters, and we have to do what then?
Multiply the radius.
Add it to the radius of the Earth, right? Because in this problem, here's the Earth. Here's the satellite, 200 kilometers away. So we got to make sure that we add the radius of the Earth to that. Okay? If you don't add the radius of the Earth, will you get the right answer?
Yes.
No. Okay? So our radius, we need to convert it 200 kilometers into meters, right? 200 kilometers is 200 times 10 to the third. 200 times 10 to the third meters, right? An easy way to convert is just know that kilo means times 10 to the third. Right?
Yeah.
Okay. What's the radius of the Earth?
6.38 times 10.
So the real radius is 6.38 times 10 to the sixth plus 200 times 10 to the third. Right? Does that make sense? Okay, does that make sense? Okay. Since we're orbiting the Earth, okay, what else do we need?
Yeah,
We're trying to find velocity.
Oh, man.
Okay. We want to know the velocity of that satellite.
Yeah, no big G.
Mass, right? What's mass?
5.97 times 10 to the 24th.
Okay. Kilograms, right?
double up.
Ready to convert that?
That's G.
No.
No. Big G?
6.67.
Omar has got this down.
Good.
Oh, it's negative? That's where I messed up.
Okay. So, to find our velocity, square root of big G m over r squared, right? Right, does that make sense, guys?
Wait, I have to redo the
Oh, it's radius square? There's no square.
Oh, yeah, you're right. Thank you. Common mistake because everything else is radius squared. My fault. Thank you for catching me now. Alright, so to find our velocity, we then plug in everything and just square root it. So 6.67 times 10 to the negative 11 times, thank you, times 10 to the 24th,
Divided by 2.
by 200 times 10 to the third, plus 6.38 times 10 to the sixth. Okay. Now it's okay if you just do that in your calculator like that, if you just add them together. Okay? So now when we multiply that through, what answer do we get?
Hey, I did it right.
You just all in one step, you get 7,779.
I got 912.
You told me it was 0.04.
I was right.
You
Why am I excited that I'm
Right.
graduating physics?
Right.
Okay. Now,
You told me it wasn't negative 11.
It is, so suck it
I thought you were talking about something else. I'm sorry.
up. Ah.
G is always negative 11, Skyler. Okay, now,
Wait, what? I got 700, 900.
okay, if you rounded any of these calculations, so like if you did like these two, and then these two, and then rounded, and then did the division and the square root, it would get a little different. You plugged it all in at one time, and got 79. Did you use like 6.3 or 6.4 instead of 6.38?
No, I used 6.3.
Okay, because if you take any little bit off, or if you round a little bit, it'll change the answer by a lot.
I said 6.38 times 10 to the 6 plus 200,000.
Plus 200,000 instead?
Same thing.
Interesting. Let me see.
Wow, Kyle, you did not get the answer.
You could have missed parentheses.
I got 7.
That one?
Now you have to divide it by something.
That's
You
my
know.
answer. That's what I
I
got.
already divided.
I just did what you did on the board though.
Don't tell me what I got.
Ah, you didn't put
It's
parentheses.
square rooted
When
it.
you do division, you need to put parentheses around the. You need to put parentheses around these two numbers.
Oh.
Division.
Caleb
Okay.
Tell me what
Does
I
that
did
make
wrong.
sense? Don't laugh at Caleb. He's
Tell me
trying.
what I did wrong.
You didn't
Okay.
use them for red.
All right. The next one. Okay. A low orbiting satellite has a speed of 65 kilometers per second. How far is it above the surface of the Earth? Okay. If you didn't try this one already, write down your list. Okay. Make your list, and we'll get started from there.
Wait.
Needle.
Can Now we know velocity.
You multiplied your radiuses, you didn't add them.
Wait,
So right here where you're
that's
adding,
decimal
you
units,
multiplied.
No.
Okay?
right?
And you need to put a parenthesis around the 638.
Why?
Because order of operations, it does division first. So you have to put the addition in the parentheses. So it's like add them first, then divide.
I get
Okay,
it.
you get it?
Mhm.
Why do we use miles?
Because when the U.S. revolted from Britain, they wanted to change everything, and that was one of the things they wanted to change. Just to be different. Okay,
Wow.
so I don't know if that's for sure. That's just my guess. All right, so V, what's the velocity here?
6.5.
6.5 kilometers per second. It's not that big. Hopefully you noticed that it's actually been getting a little smaller. Okay. Anything else we need to know?
That's the new velocity.
Okay. So that's the velocity now. Everything else, it's for the Earth, right? Right? You need that back up there, Rex?
Yeah.
Okay. The only difference is saying a low Earth satellite has this velocity. What's its radius? How high is it from the surface of the Earth? Right?
Pretty high.
So everything else here is the same. These two things, Rex, are still the same.
Oh yeah.
Okay. We're trying to find the radius.
The R.
You have to convert
Okay.
that?
Oh, so we don't know right?
So we don't know the radius.
Are we supposed to convert that?
Yes, we need to convert that because we always work in
Meters.
meters. Now the nice thing about kilometers is kilo means times 10 to the
3.
third. So an easy conversion here is just writing 6.5 times 10 to the third meters per second. Does that make sense?
Why can't we just change it?
Then we have to change with the value of big G.
Oh.
Okay. All right. So any questions?
Wait, 6.7. I don't go with those.
So we have this equation again. Because it's a low orbit satellite orbiting the Earth, that whole line is the radius, right?
Okay. Is this new?
Wait, I'm.
Well, it's the same equation. We're just solving for a different variable. Okay. Yes.
I can't get that answer.
For that one? Okay, we'll take a look at it in a little bit, okay? Alright. So now, plug in what we know. Square root of 6.67 times 10 to the negative 11 times the mass of the Earth. 5.97 times 10 to the 24th.
Parenthesis.
Coming from a guy who had a hard time with parentheses last time.
What? Oh,
Coming
yeah.
from a guy who had a hard time with parentheses last time. All right.
Okay, Kyle, when you mess
Now-
up, it's not my fault.
So I plug in what I knew, and I didn't leave room for V. So sorry about that. What?
How do you square times?
Didn't leave room for V. What's the question, George?
What is that? No, 5.97.
Times 7 to the 24th. It's the mass of the Earth. Right? So this is our equation, right? What's the first thing we should do? Kyle.
Simplify. I think you should
It's pretty sensible. It's not very radical. You could say it's kind of the opposite of being radical.
Simplify.
Get rid of the square root, right?
yeah.
Okay, we get rid of the square root by squaring it. You like my little pun there? It's kind of sensible. Not really radical. So 6.5 times 10 to the third squared. 4.225 times 10 to the 7th, right?
Hear that, Brett?
4.225 times 10 to the 7th, right? Okay. Equals. Oh, no square root anymore. We're sensible now. We're no longer radical.
Ha ha ha. You should say that on the test.
I like jokes. All right. So I'm going to simplify that top part. So 6.67 second e to the negative 11.
So you do. Okay.
Was that Kyle?
Nothing.
Okay.
Wait, we have to square that too, right?
No, because it's under the square root, so you do not need to square it.
Oh,
Okay. Squaring it takes the square root off that. 3.98 times 10 to the 14.
So we just plug that in our calculator or what?
Yeah, just do the top in the calculator. Just multiply big G in the mass of the Earth.
Oh, so you don't need the square root?
No, you don't square it because when we square it, you get rid of the square root.
So you
When-
don't have to square it either?
Right.
it's 3.9.
Right. When you square a square root, Kyle, when you square a square root, these cancel.
Alright.
Okay, so they go away.
Alright.
All right, because they're the opposite.
Alright.
All right, that's why the whole radical and sensible plum works out, because those are opposites.
So just multiply.
Okay.
them.
So now what do we do?
You multiply it.
By
Alright.
r.
Yeah.
Okay. Multiply by r. Okay. So then we have 4.225 times 10 to the 7th r equals 3.98 times 10 to the 14th, right?
Do we
So now how do I solve?
divide?
Divide by what?
4.225.
Good. 4.225 times 10 to the 7th.
Could you just multiply the other one by
By what?
Can you just like multiply the top or no?
No,
Why not?
because that's on algebra.
How's that not algebra?
Because there's an equal sign in here.
So
I
why
have
would
to get
you
the r off the bottom. You can't just multiply these together. That's not algebra.
I'm sorry.
That's illegal
Okay.
move.
No, I'm trying.
Like why is that not right? Why would that not work?
Why would that not work? Because the r is on the bottom, right? I'm trying to solve for r. So one, if I just multiply these together, r would still be on the bottom.
I didn't say that. I said
You said that.
Yes, you did. Can't you
Oh.
just multiply those two numbers together? I am filming. We can rewind it and watch it again if you want to.
okay. I'm trying to say like once you multiply the top, wouldn't R just be there by itself? Or no?
No, you can't do that. You can't just multiply these together because this is on top. If you want to move this over there, you have to divide it because it's on the top.
All right.
All right. The easier thing is to multiply by r and then divide over.
All right.
Okay. If you want to, you could write a 1 underneath here and do cross multiplication, but it's the same thing as what we're just doing because you have to divide anyway.
No, I'm good.
All right. So these cancel. What's this? 9 point what?
4, 2.
Times 10 to the. It's the 9th?
I think so.
I don't think it's the 9th.
Oh, the
3.98.
six.
6?
Yeah.
Okay, that sounds better.
They give me the right answer.
Okay, Branch, I have a question.
Yep.
So if we were to use like the whole numbers, because like when you put it into the calculator, it just gives you the whole, sometimes, well, mine gave me the whole number, not like 4.225.
Yeah, you can use the whole number if you want. That's
Okay,
fine.
so we won't get it wrong.
No, you won't get marked wrong. Now, typically I do all my answers in scientific notation, so it'll make my job easier if you go scientific notation.
What if you convert it and it's wrong?
Then write them both.
You don't have to put the
All right. So, with what?
I think I'm gonna major in language arts.
Okay, I told you to pay attention to this one. That's gonna help you out, right? Okay, so we started with this equation and we just plugged in what we knew to solve for r. Okay, then squared both sides, multiply by r, and worked our way through it all. Now, is this the answer? Is the satellite that far above the surface of the Earth?
No, it's from the center.
No.
of the Earth.
This whole radius is that number. So this whole thing right here is the 9.42 times 10 to the 6th, right?
If you wanted to find you would have to subtract the radius.
Good. If we want to find the height, we have to subtract the radius of the Earth. So we need to take 9.42 times 10 to the 6th and subtract 6.38 times 10 to the 6th.
Whoa.
Okay. And then we'll have how high the satellite is above the Earth. Now, something cool about these exponents, you don't actually subtract the exponents. So times 10 to the 6 comes down. And then we can just do long subtraction if you want to.
Oh, God, how do you do that?
Or you
3,
just use-
12,
Or do you
4,
use your calculator?
0, 3.04 times 10 to the 6th. That means that satellite is about 1,000,000 meters above the surface of the Earth.
Oh,
What? There is not.
Yeah.
Okay.
How did you?
What did you R plus H in your equation?
You plugged in all the numbers and then moved it around. Like, I just moved it around before you put it
Oh.
Just made it like-
So you're saying you move you solve this for R and then find the answer. Okay, so you're doing the same thing, you're just doing it in different order. Okay, so you looked at this equation, right? Lot? You solved this for R, so you had
R equals GM.
R equals GM. Oh, that's backwards. V over GM and the V squared. Oh yeah, I'm backwards.
Can we see a picture of you when you were a kid then so we can prove
See
it?
this? GM over V squared.
I said
That's fine.
It reminds me of when we
Now, that's okay, but on the test, I'm going to give you equation 7. I'm not going to give you that equation. All right, otherwise I'd have like 28 equations up there if I solve for every variable. So if you're content doing that every time, that's fine. But some students struggle with variable manipulation without numbers.
Me, I do.
Okay? So for you, that might be easier. If it is, great. Do it that way. Okay? For others, they like working with the numbers instead. Okay? I thought you meant there was a shorter method, like we just had to add 2 numbers together to get the answer. All right. All right. Any other questions?